G'day, Andrew Price here for another Blender Guru tutorial, and in this video you're going to learn how to make this smashing glass bullet animation. Fairly specific, I know. Some of you watching might be thinking like, when on earth would I want to make a bullet smashing some glass? But the things that you learn in this tutorial should be applicable to a whole variety of different destruction needs. So, you could use this tutorial to create, say, a tank plowing through a wall, I don't know, a house blowing up, a grenade exploding, basically anything to do with destruction. So the way we're gonna, what we're gonna be using in this tutorial is the fracture modifier to make an object split into hundreds of objects, and then we're gonna be using the rigid body simulator to make them interact and simulate fall, gravity, that kind of thing. Rigid body constraints to make some objects attach to others so that they have a little bit more of a, I don't know, weird, better look, essentially. Then we're going to use the particle simulator to create the even tinier shards coming off those shards. And then we're going to use the smoke simulator to make the fine dust cloud that would appear. So a whole variety of different things. And all this stuff that you're going to learn is stuff that I had to learn the hard way. So I started this project about a month ago. And if I knew how much work it would have been, I probably would have never started it, honestly. It's been one of the most grueling tutorial preparations I've ever done, because I got started and realized that a lot of this stuff just is not documented. A lot of the tools are very wishy-washy about what you're supposed to do with them, and so I just thought I'm going to try and figure it all out, and it just took like a month. This tutorial was supposed to go up about 3 weeks ago. But anyways, so I've learned it all, and I'm going to be passing on those tips and secrets onto you guys, the listener. So without further ado, let's go ahead and get into Blender. All right, so the first thing we're going to do is delete the default cube and the lamp, and we are going to replace it with a plane. And this plane is, of course, going to be our sheet of glass that the bullet is going to smash through. So we need to give it some thickness because at the moment it's paper thin. So I'm going to go ahead and add a solidify modifier, which basically just adds a little bit of thickness to every face. And we're going to hit apply on that with the default settings so that it's now actually part of the object. Cool. So now we can get straight into it with fracturing it. So breaking it up into little pieces. And this can be one of the most, I don't know, yeah, just really intimidating things if you've never done it before and you're trying to go it alone. So what we're going to do is we're going to use a new tool in Blender called the Cell Fracture add-on. So this was one that was created by the Blender Foundation, if I'm correct. Yeah, Fimax, Sergey, Campbell, they all worked on it. Anyways, pretty solid. It's a little confusing though if you're just getting started. So yeah, to load this in, just type in frac, and you'll see cell fracture selected mesh objects. That's it. You click that and this is it. So this looks really confusing when you first, open it up, and you might be thinking, do I need to learn all these things? It can help, but it's not necessary. For one, we're not going to use recursive shatter, and we're not really going to use any of these other settings down here. It's mostly just what's at the top here. So essentially, the way of breaking up an object are these options here. So you've got 5 ways of breaking it. Using its own vertices, so each one of its vertices would be a separate object. So if I just hit OK on that, that's now broken it up according to its vertices. So there's 8 vertices. So if you go to the second layer, which is, by the way, where it puts everything, it puts it on the next layer. That's where you see the results of everything. You can see we've got 8 objects here, right? Not very useful, but it could be useful for some things. The other ones you've got are child vertices, and this one can be kind of useful. By the way, I'm showing you all these settings here just because they can, just because they can be useful depending on what sort of thing you're, hang on, what am I creating? Control Shift A. Oh, there we go. All right. Forgot which button to push to actually bring an object in. Rookie move. So let's say I've got this view here and I parent it to this plane. It's now technically a child of this plane. So if I then use this, I could go child vertices And then if I hit OK on that, you can see it creates some much more interesting looking objects. And this was actually the way I created, like early on, my first bullet animation. And it's okay, but it doesn't give you much control over everything. And you can see it's just looks like a star, imperial flag or whatever coming out of there. Not that good. So the other ways I'm not even going to show you own particles or child particles. That's just setting up a particle system and it'll just give a shard for each particle. Not useful at all. The one we're going to use is grease pencil. So if I just did this right now, nothing happens basically because we haven't got any grease pencil. The grease pencil, for those who don't know, is the tool that allows you to paint basically anywhere in Blender. This is the grease pencil. Wonderful, marvelous invention. No, it really is actually. Little fun fact: grease pencil comes from the name of animators. They used to actually draw on their monitors with a crayon or I think a greasy pencil. I should have really thought that fact through before I started explaining it. But basically, so they could ghost in the next frame. So they drew on their own CRT monitor or whatever. Anyways, okay, the grease pencil. To get this to work with the with this plane here, you have to make sure that it is applied to the object. Do not click scene or else it'll be all wasted and it won't work. It has to be applied to the scene. So click new object scene. Yeah. And let's just do, I don't know, a couple of lines. Like this, all right? Now if I go, grease pencil, okay. Ooh, more interesting, look at that. So, the way this has worked is, let's see if I can select, okay, there we go. Each line that you draw will become a string of shards. And if there is a gap between lines, it will create a crack there. So when I first started, I thought that actually where you painted was actually going to be a crack, but you can see here that it is between the two lines. So let's just do another example. Let's remove that. Let's try this. If we paint a circle like this, just draw a circle, rough circle. Doesn't really have to connect, although it sort of matters that it's at least close. Let's draw another circle there. Let's do that, and you should see we can now get something that looks a lot more like something has impacted in the middle there. And so this can be used to create a whole variety of different impacts, because leaving it entirely up to the software, I've realized, when it comes to fracturing isn't ideal, because unless you're using some really expensive software, it's not going to get the fracturing right. So it's usually based off a generated texture. In this case, it's the Voronoi texture, which is pretty good, but it can't estimate how real materials break very well. So you really have to find images of how something actually breaks in the real world, and then you have to paint it. Really annoying. I was against using grease pencil first because I thought, no, I want it to be authentic. I want it to... I don't know why I thought leaving it to the computer would make it look authentic, but I did. So anyways, what you need to do is actually look up photos of something that looks close to the way you want your object, whatever that is, to be shattered. So I learned through researching this that no two sheets of glass shatter the same. Like, so you got some glass which shatters, you know, like that. What do you call that? It looks like that sugar glass that they use in movies. Stuff which is designed to be resistant to impacts. And then you got like stuff that's like from a car windshield, like that square stuff that's not supposed to look sharp or whatever. Every shard, every glass just seems to break completely differently. I'm a fan of this type of glass, like this sort of webbed, cobwebbing sort of thing. And it looks pretty cool. So you just want to download one of those images. So there's some images here. I'm just going to use this one off Flickr. It's got some sort of interesting rings and stuff on it. So I'll just go ahead and I'll download that. And then you just want to go into the properties panel and load in the background image. Just load this in here. Didn't give it a name because I ain't got time for that. And then just like if you're modeling something from scale or whatever, you just want to scale it down till it fits the scene. And I want to get the impact relatively sort of in the middle there, just something like that. All right. Now the aim of this is our when we do this painting. we want this to match where the sort of the string of shards sort of is. So you could see we've got this string. So if you can imagine like each one of those shards has like an origin point, that's what we're supposed to be drawing along. So I'm just sort of in the middle there like that. And then I'll draw another one here. And actually I've found like for this middle part, like if you've just got a whole bunch of complicated stuff, I find if you just draw like a spiral, just go like crazy in the middle there, it actually looks pretty cool. And I'll do another one like here. I'll just go around like that. Actually, I'll do another little spiral thing around that, because that can create this cool sort of like Voronoi sort of looking stuff. You just learn things from sort of playing around with different grease pencils sort of look. You can also, by the way, if you want like big shards, like you can just go like do a little dot, and then each one of those shards, sorry, each one of those dots will become a shard, like a big large one, you know. Anyways, this looks I'll do a little double one there as well. Okay, so that looks terrible, right? Like from just the viewport. But if we do some fracturing, let me just check these are all the default settings, because I actually had to restart this recording. I don't know if you can see the little jump cuts when I do the recordings or not. Anyways, just generating this on the grease pencil at 100 pieces, and there you go. So that actually looks pretty good. Like, obviously, you know, in comparison to the photo, the shards are way too big. Like, they're massive looking things. But you can fix that if you just increase the number of this source limit, which, I mean, really it should just be called objects, or like, you know, piece limit, shard limit. I don't know what but anyways, the number that you give that will become the number of objects that it's actually broken into. So the higher you set that to, the smaller the pieces will become. But also, if you set it too high, you can get it where they kind of overlap and they start to, like, I don't know, cut into each other. But yeah, you can see in the top right hand corner, you can see it's got 200 objects there. So it's exactly 200. So that's where that source limit comes from. Spending a lot of time describing this, aren't I? Okay, so this looks pretty good. It's not too bad. What I will do is I'll change a couple of things here. The end amount that I'll give it is about 500, but just for now, I'm just going to leave this at 200 because I want to explain a couple of the other settings you can tweak. One setting a lot of people tweak is the noise value. And what this will do is it'll basically, like, you know, that Voronoi cell, like cracked dirt sort of texture, you know, the one like the generated texture. It basically creates, like weaves that into the grease pencil process. And it's all right. But you can see it sort of mixes everything up. Like, it sort of blurs it a bit. So I'm not a fan of it. I'm not a fan of that noise thing. I think it's probably only useful for like ceramic maybe. So I'm just going to leave that to 0 because I think it removes some of the detail and stuff. The other big one a lot of people use is the recursion. Now, I am against this. I actually spent like a week just like tweaking this, like just going through it and like experimenting, looking at it, deleting it, retrying it. I've got no life. And I've come to the conclusion that recursion really doesn't have much of a use. The reason being that, okay, so just to explain what recursion does is after it does the that process before of like breaking it up into individual pieces, it'll then take those individual pieces and break some of them up into even smaller pieces. So, okay, doing it once, that'll do it once. 2, I don't know why you'd use that, but it will then break those tiny pieces into even smaller pieces again. But anyways, I'll just show you why I don't recommend this. Like, if we just set that to that, and I'll just hit OK on this. Let's just see how this looks. Okay, so this is the initial process. So it's putting all the cells over the plane, and then it's doing like a Boolean operation to kind of subtract from it. And then, see that? This little operation here, this is the recursion. So it's doing that extra bit afterwards. Which is, the reason you'd want to use this is that in a simulation, like destruction, the smaller the pieces, the more realistic it's going to look. Like, just when something is breaking in the real world, there's just pieces everywhere. Like the fine dust particles, you know, that comes from when you hit, you know, anything like a hammer with a brick, the other way around. That's tiny little particles. That's just tiny, tiny, tiny little particles in the real world. So that's what recursion is, supposed to be, it's supposed to be useful for that. However, I found that Blender's just not stable enough for it. Like the rigid body sim just can't handle the tiny little pieces, or the way this fracture object does things. It doesn't put precautions in place to prevent what I'll show you in just a second once this thing finishes. All right, I'll just pause this while. Hey, okay, so it's finished. All right, so this is why, you'd want to do it like, oh, look, it's got all these extra little objects there. That looks a lot better. And it kind of does. But if you zoom right in here, you'll see you've got this. Now, this will destroy a rigid body sim. Just to demonstrate it for you, I'm just going to very quickly just enable. You don't have to do this, just so you can watch and see what happens. Don't do this at home, kids. All right, I've just turned off gravity just so that we can see how this looks, right? Look at that. See? So if you wanted to, I don't know, have a spaceship that destructs at frame 1 of your animation, what was that? Did you see that? It was like a blue flash. I swear, either I've been spending way too long on this tutorial or that just happened. Yeah, it's exploding just because there's these tiny, 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 tiny little things, and it's just hell for a simulation. So if I deleted those, that area there, I mean, see, you can see there's way too many of them. So that's why I don't like recursions, because the rigid body sim, it just can't handle these tiny little artifacts that it leaves behind. And unless you plan to go through your entire, every single shard, which I actually did at one point, and it took over an hour, and I still didn't get them all. You just can't fix that. So that's why I don't recommend recursion. Instead, what we're going to do to get those small shards, because that's what's important, is we're just going to be using particles later on, which I think, once you tweak a few things, you actually get better control over the particles. Anyways, so we're not using recursion. We're going to increase this to 500, and we're not going to use noise, and we're going to set this margin amount. The margin is the gaps between the shards, the cells, right? So the higher you set that to, the bigger the gap. The lower you set it to, the smaller the gap. You obviously want to go lower because it makes it look tighter, and it also means that because it's doing that boolean operation, like subtracting, like putting the blocks there, then subtracting from it. Because it's doing that, the smaller you set this to, the smaller the individual shards that you're left with can become. So that's why you'd want to go low. However, if you go too low, then again, just like what you saw, stuff will explode. You don't want that. So just experiment with this. If you find that stuff's exploding later on, just come back to this and go like, all right, I'll fix that. I'll just go a little bit higher, and then just do it again. That's the value I'm going to set it for. That should be good, I hope. You never know what you're going to get. But let's just see how this looks after this is finished. All right, so this is our end result. Now, let's just very quickly just add it as a rigid body, just so I could see if it is exploding. No, look at that. It's a solid animation. I mean, solid fracturing, because that's a good result. If, by the way, you'll only see that if you have gravity turned off in your scene settings. The reason we're not using gravity, by the way, is we're going bullet speed. So very, very unlikely you would see shards falling in a bullet animation. Stuff is flying everywhere. The gravity is almost unseeable. The other cool thing, that's not a word. The other cool thing about having zero gravity is it means that you don't have to do what you would normally do. Like, let's say you've got gravity enabled. When you animate it now, everything is falling. What you can do in the rigid body tools over here is you can enable deactivation and start deactivated. And okay, well, that didn't work. Oh, copy from active. Okay, there we go. So that will freeze everything until a force of this magnitude hits it. That can be good, like, and you'll have to use that for things like if you've got a scene that's got world gravity in it and stuff. You don't have a bullet. You can't get away with zero gravity. But it does introduce a few glitches. Like, basically, it's like frozen in this one state, and then once something becomes active, stuff can get a little bit unstable. Like, stuff can explode, things can get a little bit weary. I don't know what that means. I'm making up words right now. But anyways, thankfully we can get away with with 0 gravity and just having that turned off. All right, so this is what we've okay, so this is what we've got. This that's a good result. If it's not moving, that's fantastic. If it is moving, if you're finding some areas, like maybe you got one area where it's just sort of blowing up for whatever reason, try either going in there, and if it's just one area, like maybe making it a little bit smaller. And what that'll do is usually it can be a problem with the margins, like there's not a big enough gap and something's touching, so that can fix that. Or what else could it be? You could have one of those, you know, if you've got like individual, like 1 or 2 vertices that are in there, that can be the problem. The reason I'm telling you this all, by the way, is that it's just such a big problem. Like, it can really suck the will out of finishing a project if you just have this stuff exploding for no reason. So I'm just trying to list all the possible reasons it could be. You could have another object near to it, which of course you would do if it was a shard, but sometimes let me just try to think. Yeah, that's pretty much all the reasons. So the other minor, you might need to enable split impulse. Very, very rarely, but that can kind of fix things a little bit in some situations. All right, that's just, yeah, a little bit of nonsense. I'll turn off this background now, and great. All right, so one other thing. We can actually remove this from the rigid body because there's one other thing we need to fix, and that is the doubles. So if we hit Control J and make this one single object, if we now hit W, remove doubles, look at that. Top right hand corner, 9,704 vertices removed. Like that, set that to as low as it can go. Yeah, that is a lot of doubles. Doubles means that on one spot, you've got one vertex resting exactly over the position of another, which is not good. So for whatever reason, the fracture modifier just creates, the fracture add-on, whatever that thing was, this thing, that creates a whole bunch of doubles. And that can be a problem, not only for the shading of the objects, it can also wreak problems in the rigid body sim. So you want to get rid of that. And that's the way to do that. To make it one whole object, so you can just get rid of it in one go. And then to make it go back to its individual objects again, is you hit P by loose parts. It'll take a while to figure out all the loose parts again. 1, 2, 3, go. Awesome, how good was that timing? Then hit Control, Shift, Alt, C, origin to geometry. And there we go. Now we've got the original objects again. And now, yeah, let's do that rigid body stuff. So let's go add active. Let's just check they're not moving again. That's good. And the one final thing you want to do, like all these settings here, we don't need to tweak them. Like all this stuff here, we can just leave these as they are. The default values are actually pretty good. Convex hull, mesh, you don't need to worry about any of that stuff. I've been through it, and actually the default values work squeaky clean for this, which is great. So the one thing you do want to change though is the mass. So by default, it gives everything a mass value of 1 kilo. So everything from these huge shards all the way down to these tiny little shards down in there. Yeah, 1 kilo, or I don't know, for the Imperial people, 2.205 pounds. A nice round number, right? So it's way too heavy. So what you want to do is enable calculate mass. So in the toolbar here, with everything selected, calculate mass, and then base it off of one of these presets here. And I just wanted to mention one thing. Oh, look at this. You got like some sensible things in here. You know, air, acrylic, beans, a little bit obscure, brick, bronze, cardboard, concrete, charcoal. You know, all these things, you know, sort of make sense. Okay, go down the list, gonna paper. Peanuts, shelled, not shelled. What about half shell on, half shell off? Why haven't they got that value in there? I don't know how that made it in there. Why is peanuts on there but not macadamia nuts, you know? I don't... Anyways. I think it's just fascinating how, like, I want to know, like, the backstory. How did the peanuts get into the calculate mass presets? And why was there 2 options? So the one we want is glass broken. So select that, and now you can see, like, these values are like, you know, 46 grams, 78 grams. They should all now have a different value, which is exactly what we want. All right. Fantastic. So now it's sitting perfectly stable. Now we can get into the bullet. Actual bullet, not the simulation. Well, that's involved as well. All right, bullet. So the bullet, obviously it has to have a force to it. So we're going to go through that, like how to actually give it a force. But first things first, let's actually model it. So it helps, before we start, obviously, look at reference photos of an actual bullet. Just every little bit of detail helps. I used to think it was a cylinder. It's really not. It's actually sort of closer to a half UV sphere. Like this is the one that we're going to make, like this little one here. There's all different types of bullets that you can see, like, you know, armor piercing ones and whatever. We're just going for one that looks like that first one, right? So we're actually going to start with a UV sphere because that's the hardest part to model. Like if we were to start with a cylinder first, that would be a nightmare later on to try and add that detail. So by starting with a UV sphere, I can then delete the bottom half and then create the cylinder. So that's a little meaningless tip that everybody knows, I guess. Anyways, so I've added that bottom piece to it. Now I just want to, just for that little extra bit of detail, I'm just enabling the proportional fall off at the sharp value, and then I'll just pull that down till it's got like a little pointed hat. It's not too spherical. Yeah, a little bit pointed like that. And then I'll just make that a solid object, solid face at the bottom. That's it. Rotate it, scale it down more. And that's pretty good. And then I'll just apply this rotation and apply the scale. It's always good to get into the habit of doing that, especially when you're doing simulation stuff. Cool. So now we can go to the rigid body, enable rigid body right there. It's got a massive 1 kilo, but doesn't really matter. All we want is for it to plow through it. So even, you know, this is 48 grams, this is 1 kilo. What's going to win? You know, it doesn't really matter, okay? If we were to enable this now, it's not moving, it's not doing anything because the gravity's turned off and it's just sitting in space. So we want it to move. Now, I was always like puzzled by this because I started Blender like when you could only do it with the game engine and you had to add controllers and stuff, and it was just a nightmare. It's a lot easier now. Like, this is all you need to do, right? So you go to the graph editor and then you just animate it like you would normally. So you animate the start of like where the force starts and then where it's actually going to start its simulation work. Maybe it's just easier if I just show you. So start the location, like create a keyframe at the first frame for the location, right? And then let's just jump forward to frame 10. I can't remember the shortcut for that. What is it? Shift up? Oh, it is shift up and back. All right. And then I'll create a keyframe at frame 10 for the location as well. And you can see here that we're not using the Z or the Y, so I'll just remove those. And then we don't want it to taper off, so I'm going to hit T and then hit linear. So it's now just a continuous thing. But you'll notice that this is not moving. It's actually just sitting there. And the reason it's doing that is because you've got rigid body enabled. So rigid body is overriding this animation data. If you turn off rigid body, suddenly the bullet will move. Turn it on and it doesn't move. And that's all well and good, but then how do we actually give it that starting force if it's not actually moving at all? And the way you do it is this. If you check enabled, it now uses the animation data. If you uncheck it, it then uses the rigid body data. So what you can do is animate that checkbox. I always forget that you can use that. And then you see it in a tutorial and you're like, oh, I forgot I could do that. So this is what you do. You go to frame 9 and you enable animated. You check that box and then you hit I, hovering over that. And that'll create a keyframe. Then you go to the next frame, you uncheck it, and then you hit I again. And now, if we animate this, check this out. Boom! How you like that? And that's it. That's giving it the force. I like how it's like the bullet is like twisting because of the it's interacting with that glass there. And that's pretty much all you need to do. How cool is that? You've now got something plowing through something else and it's being affected. Really cool. So a couple things you can tweak. One is I think that's way too fast. So if you want to reduce the speed of the object, then you essentially change the amount of distance that it covers in this initial period. So this is kind of like where the animation, the simulation gets its reading for like what speed everything should be at. So if I do it at that instead, it's now going a lot slower, which is sort of the yeah, a speed that I like a little bit better. I'll move that down even a little bit more. Super slow-mo. And that is pretty good. The other thing you can do as well, if you want the bullet to be more affected by the glass, I turn the mass down to 100 grams, and you can see like now it's like really slowing down when it hits that glass. Because that's the other thing, like I posted some of these early stuff on Twitter, and a lot of people were saying like the bullet should always be traveling faster than the shards. But that's actually not true. It really depends on the strength of the glass, because if a bullet tries to hit bulletproof glass, then obviously the bullet stops. So it really depends. Like some glass is like really sticky, really like secure, and in which case the bullet will really take a hit and all the shards will fly everywhere. So it really does depend on the type of glass. I like this hit like where the bullet looks like it's really slowed down by the shard. So I like that look. Trouble is that in this example, our bullet is really, it's only taken what, 5 shards with it, which is not good. Like, oh dear, what have I done? Yeah, we really want it to take more shards with it. So you can cheat. You can just scale up the bullet, just make it look a little bit bigger, and maybe position it a little bit into some of those bigger shards there, and that'll help take a few more with it. You can see those shards are really flying now, which is cool. But one other thing you can do, and this is what I recommend, is you can use rigid body constraints. So a constraint is this one right here. And what that'll do is it will enable you to lock one object to another object. So you can make this shard here be slightly sticky to this shard. And the reason you might want to do that is that, like in the real world, if a bullet goes through a sheet of glass, or I don't know, a plate is dropped on the ground, I was trying to think of another example, like things aren't just magically falling apart. And that's what I think is one of the problems with a lot of simulations, especially the fracturing simulations, is like everything just appears like it looks like a puzzle that's being dropped on the ground. Like all the pieces just magically spring everywhere. And it looks fake. Like it doesn't look like anything's tearing, anything's ripping. There's none of that data that you see in the real world. You don't see data, but you see the result. You know what I mean? So you want to have objects actually pulling other objects just slightly before they break. So that is why rigid body constraints can come in handy. So this is how you normally set up. You go rigid body. Okay, the name of this object is 998. This is really, really tedious. And this is how I first thought you had to do it for like every single shard one by one. And I spent, I don't know, like an hour doing this for like a whole bunch of these objects one by one. And it was a nightmare. Enable the collisions, breakable. Let's go something like that. And if you do that, you can see those objects are now stuck together, which is cool. And then, if you want it to break a little bit, you'd, change the threshold of that. And eventually, yeah, you can see now they're breaking just slightly. Now, doing it for every single shard, like it's a nightmare. Do not do that, okay? And I've learned this from watching somebody else's tutorial. There's an add-on for that. And it is, what's it called? Bullet Constraints Tool. Yeah, this one. So I'll give a link to this on Blender Guru. And it's this one, the Bullet Constraints Tools. And what you do is you download that. It's a zip, and then you just, extract the zip, and then go to User Preferences, Add-ons, Install from File, and then you just click that .py there. That one won't be there. This one will be. Install from File, and then where is it? I think I maybe already had that one in there. That's why it says that error. But anyways, this is it right here. Bullet Viewport Constraints Tool. Enable that. The little error message there, by the way, means work in progress. It's a nice way to like exude like all get rid of all responsibilities for the add-on. It's a work in progress. If it breaks, it's not my fault. No, that's I'm kidding, by the way. The developer who made this, I really appreciate it. It saved me a bunch of work. I'm not in any way dissing you. This is the way to do it. Okay, so you select everything. Once you've enabled that add-on, if you hit T, go down to the miscellaneous tab there. And look at this. Look at this nightmare of a settings. You've got basically a few ways you can do this. Like this, what this will do is it will add constraints to a whole bunch of objects. It will search them out based on this value, find its nearest neighbor, and then connect it to it based on like these mass values that you give. So it's like a way of bulk constraining a whole bunch of stuff, which is what you need for stuff that's breaking. You can do X constraints, which I found there's a bug, I think, because the breakable value doesn't apply to it. So we're using single constraints, which is just as good. It's fine, and it keeps it cleaner as well. So you just what we're going to do is down here you've got these grayed out values, but if you click it, it enables it. It's a little bit confusing. Enable both of those, and then the breakable amount is the amount of force required before it actually breaks. And you have to set this to something like really low. And then I'll set that to absolute so that it uses that value for everything. Otherwise it tries to multiply it with the mass and it gets weird. Then I'll set the search radius to be 0.2. You want to try and set that to be as low as possible. Otherwise it can try and find objects which are further away from it, which is not good. And then you just hit single constraints. And now you know that it's working because you can't click anything and Blender will think that it's not responding. Windows will think that it's not responding. It's actually working. It's doing something in the background there. I used to think that whenever Windows said this message, that it was always right. Like, oh, it's actually crashed. I should hit close program. But no, Blender just actually is working. I hope it is. Good grief. I hope it doesn't actually crash now. That would be highly, highly frustrating. Please work. Please. All right, I'll pause this. I really hope it comes back from this. Hey, it did. Awesome. Okay, it didn't crash. That's great. Okay, so now if you zoom in here, hey, it only found a couple. Okay, you can find the ones that have been constrained because there's a faint like parenting line to it. And in this case, it's actually got it wrong. It's only found one. Hang on a minute. That's not right. All right, let's try that again. And let's increase the search radius to be 0.3. I'll just make sure that the scaling of all that is correct as well. Reset the scaling. Search radius, single constraint. I'll remove all the constraints and let's try that again. Okay, so that hasn't got the, there's only a couple there as well. All right, hang on. Okay, I got it working. I just had to increase the search radius to 1, which is crazy high, but yeah, it seemingly found all the correct neighbors. You can see it's got like this kind of like spider web. Like it's really hard to see on this monitor. I mean, in Blender, really. Tiny little dotted black line on a gray background. Let's bring up the UI stuff again. No. Yeah, it's all there. So all the relationship lines are in place. So now let's just see if we animate it. Hey. Yeah, I think it's working. Let's turn off breakable. Let's see if that actually, because by having everything in it set to breakable, it means that the objects can actually separate. But if you leave it as not breakable, unbreakable, perhaps, does that actually update it, or do I have to do everything again? Okay, doesn't update it. All right, remove constraints, find them again. Let's see. Okay, let's see this with breakable turned off now. It's like, that's actually kind of cool, actually. So that's what constraints are in a nutshell. Now it looks like it's some sort of underwater creature. Like in one of those like science documentaries. We've discovered a new animal. Look at how he moves. Everyone goes, oh, that's... simulations are funny. All right, so it is working. We just need to... I did have breakable. All right, remove the constraints, and then I'll turn on breakable. And yeah, you basically want to set this value to be something like 0.0. I mean, it really... I've done this. This is why I'm having trouble with this. I've done this I think 3 or 4 times today using the values that I just used, you know, 0.3, 0.001, and everything worked fine. And then you start the tutorial, and then almost on cue, everything just breaks. Anyways, let's see how this goes with some of these adjusted settings. All right. Yeah, it's had the same result again. Let's see. This should allow me to update the selected. Okay, good. So it has changed the threshold on all of them without me having to do it again. So then, there we go. Okay. So it should have basically the value that you're looking for is one where it doesn't rip apart immediately, but it does break, but it does bring the other adjacent values with it slightly. Okay, so that's too much, obviously. Let's bring that down to 0.002. It's a little too much again. We could increase the mass of the bullet. Let's go 400 grams. This is where it kind of gets fun. Like, you can play with physics. Like, how heavy is the... And it's got that wiggle and stuff going on again. All right, I might just... I'll move that back down to 200 grams. And I'll set the breakable threshold to be 0.0015. Update that. And that should let it through. Really? It's really, really fine. These, like, sensitive, I mean. All right. Okay. All right. Well, hang on. Now I feel like I'm going lower, and it's just not really having any effect. But yeah, basically like that. That's kind of what you want. I don't know if that's maybe too much, too little. Maybe I'll add a little bit more weight to it. But you get the picture. I mean, I could just spend the rest of, you know, an hour tweaking everything, but you get the idea. You play with it until you get something that looks right. You have a look at reference videos, photos, whatever, until you get something that actually seems to look right. But this is actually pretty good. You know, these values, you know, these ones are stuck together, which is cool. So it sort of looks like that sticky glass from windshields or whatever. And then there's some that are split, and it looks actually fairly decent. Cool. So we've got it. We've got the simulation running nicely. One extra thing, actually there's two extra things. This doesn't look realistic. We've got the, you know, the base of the object breaking up is fine, but in a real world, you know, in a real video of a bullet going through glass, like in the real world, there's stuff everywhere. Particles galore, like I said. The smaller, the finer shards you've got in your animation, the more realistic it's going to look. Now, this is chunky. This is like somebody threw a golf ball through a wall of Lego. This does not look realistic at all. It needs to be a lot finer. But we can't do that. As I said, the recursive fracture tool just messes everything up. So we're stuck with this thing. What we can do instead, though, is use particles. And that actually works pretty fine once you tweak these things. It took me a long time to get the particles to work well as well. So I'll show you the way we get that to work. What we're going to do is I'm going to give a particle simulation to everything that's in front of this bullet. So everything where it's actually breaking, and I know that the bullet is going to pass through it. Because what we're going to do is these particles aren't actually going to be moved when they're born. Like, they're just going to be born on each of these shards, and then it's going to wait for the bullet to pass through it, for the bullet to actually push the particles out. It'll make a lot more sense if I just show you. So let's do that. So I'll give a particle system to this one here, and wherever, you know, find the time that the bullet actually hits the object, which in this case is about frame 13, like the frame before the bullet hits it. So frame 13, set the start and end particle frame time. So everything is born on frame 13. Just for now, I'll set the emission to 20, and I'll set the lifetime for all the particles to be 200 frames. And I'm going to reduce the emitting for like the velocity to be 0, so that if you look at it now, the particles are just born and then they're just stuck there, and that's what we want. And then I'm going to apply that to everything. So I'm going to hit Control L and then hit modifiers. And now they should all be birthing particles. It sounds weird. Birthing the particles. And then they're just left there in space. But one thing you can do is for each of these shards to make them sort of interact with the particles as well, like when they move around, you can enable a collision modifier. Simulate the collision. It's just this thing. It's the exact same thing. It's just going into the physics panel, hitting collisions. Just do that. And then go to particle dampening, increase that to 0.5. That'll increase, like change the amount that it bounces off it. And the particle friction, I'll increase that to 0.5 as well. So that basically they don't all spray out in an exact manner, but they have some, you know, randomness to the way that the bullet hits them and stuff. The way the shards interact with them. And then I'll hit Control L and then hit modifiers. Now, what that should do is it should put that collision modifier on every single one of those objects. But for some reason, and if any developers watching, I don't like to put my requests in a tutorial. Well, you know I do like to do that. But I don't know why that does that. But it copies all the modifiers except the collision modifier. And I think that is a bug. But anyways, the way to actually do it, like the way around it, I found, if you use the copy attributes menu, that just comes built in with Blender. So that one's easy to find. Just type in copy. And then if you hit Control C, copy selected modifiers, and then hit collision, and then hit OK. Now they all have the collision modifier. Okay, I think that's a bug. Someone's going to have to tell me in the comments whether or not it is. Okay, so now if we do that, some of them might move if they've hit another shard, but not likely yet. The main one is that the bullet has a collision effect on it. So we increase that, just like what we did before for the others. And then, boom! Look at those particles flying everywhere. And that's fantastic. So you wouldn't believe how long it took me to get these settings just right. The idea that the bullet's actually pushing the particles out. Before that, I experimented with the normal velocity, the object velocity, all sorts of different things. And it just looks horrible unless you have the actual simulation affecting the force of particles and stuff. So there you go. So now we can just increase the emission value for that. And now, boom. Stuff everywhere. Oh. Great. Awesome. So now what we want to do, obviously, you know what I'm talking about, is set each one of those particles to be a shard of glass as well. So what we're going to do is, basically, I'll just select a whole bunch of these shards here. Let's just go. These all look pretty interesting. Yeah. All of them. All the good stuff. A couple of big ones. Maybe not too big. Like that. I'll obviously get rid of the bullet. Obviously. And then I'm going to hit Shift D. And then I'm going to move this to its own layer all by itself. And we want to get rid of every simulation, anything that's affecting the simulation. The collision, the rigid body. Actually, for the rigid body, you need to go to the physics over here and then hit remove. For some reason, some of them are still in a group. So I'll just hit, I think it's, yeah, those that are using the constraints. It says that. Remove from all groups. And you want to make sure that they all have no modifiers. So I'll hit Control L. Modifiers, and now they're all just blank pieces, just doing nothing, which is good. So now I can select them all, hit Control G, and what I'm doing with these is giving it a particle group name called shards, and then now, for our actual particle system over here, I can go down here to render, go group, and then select shards. So now those shards are birthing individual tiny little copies of themselves, which are then going to be spread out everywhere, which is pretty cool. Rotation, you can enable dynamic. I don't know if that will actually, I didn't check that in my tests. Does that actually affect the rotation of them? Not likely. Rotation's weird for particles, I find in Blender. Like it's not, I don't know, they don't rotate like they should. I just want it to, rotate like a normal particle does. But, velocity, give it a little bit of, no, randomness. Did that do anything at all? You just want them to just spin, just slightly. Okay, they're kind of moving now a little bit. But you don't want them all to be in sync. Anyways, all right, getting into the finer details of things. But that's pretty good. And then underneath render settings as well, you want to increase the render size. You can see it looks a lot better now as well. And then you can increase the actual size of everything as well. And look at this. It's getting somewhere. It's looking pretty good. Awesome. So it looks pretty good. We got large scale detail, medium scale detail. Now, to complete it, you really need that fine level detail. So in this case, it's the particles that are even smaller than our medium particles, and that is basically dust. That fine puff of smoke and debris and stuff that should come off this this wall here as it breaks. So to do that, we're obviously going to be using the smoke simulator. So it took me forever to actually figure out the best way to do the smoke simulator for this example. I originally had it so that each of these little bits were like emitting smoke, and then it ended up looking like a firework, and I couldn't figure out why. But yeah, basically the best way to do it is to have like a small object here that creates one swift puff of smoke and then sort of blows it across the scene. So that's what we're going to do right now. So if we move these shards just to, let's go this layer 6, and what I'll put here is the domain cube, which is where the smoke simulator is going to be generated inside of. And I'll just move this over because obviously the smoke's going from right to left like that. All right, and so right here, like right where the bullet impacts, I want to put a UV sphere. And I'm going to rotate it, and I'm just going to delete half of it like that. And I'll just scale this down just so that it fits roughly the size of the bullet. Yeah, like about that size. Awesome. And I'll put it just behind the glass just a little bit. And, oh yeah, move that over to the new layer as well, layer 3. Great. Cool. All right, so, yeah, first things first, let's just make this a smoke domain like that. 32 resolution should be fine to start off with. And I'll use adaptive domain, which is very important. Probably the coolest feature actually added to any simulator in Blender in a while. Adaptive domain just makes it so you don't really have to worry about the size of the domain anymore because it adapts. Pretty cool. And I'm going to set the start and end frame to be 100 frames because that's all we're generating. Turn off the gravity, just like the rest of the scene, and everything else is fine there. So this is the smoke flow object, where obviously the smoke's going to be emitting from. So we need a particle system first to create that puff. Like you can now create the object based off its mesh, like that, but then it would be, what do you call it? Just a continuous stream of it, so it wouldn't look good. So it has to just like appear and then disappear to create that puff. So that's why we're using a particle system. So we want the puff to appear obviously once it hits the wall. Sorry, once the bullet connects with the glass, which is about frame 12. And I want the lifetime to just be about 2 frames. Yeah, and this is probably the most important value for this. And that's the emission amount. If you set it too low, then you won't see any smoke at all because it's only appearing for like 2 frames, like I said. So you have to give it like 1 million particles, which sounds extreme, but it's sort of what you need. And then I also want to use a random amount for the velocity. And that's important because otherwise these particles will all share the exact same space when it's sprouted. And it'll look a little odd. So you can also use the random distribution there, and that'll help with that as well. And that should be good. So I've just listed off a whole bunch of settings, which isn't very exciting. But now that we've done all that, I mean, it's just basically making something puff a whole bunch of particles for 2 frames, and that's it. So we then go to the flow settings, enable the particle system as the flow object, and then use initial velocity. So that creates, and that's really important. If you don't check that, then it's not really going to go anywhere. So it needs to use the velocity from the particles to actually throw the smoke across it. So now that we've done that, well, first of all, we need to bake just the particles, just so that they're saved into bake. I wouldn't use bake all dynamics, otherwise it's going to try and bake also all of the rigid body simulation, which would just take forever. So now that I've done that, I'll bake this smoke as well. And this shouldn't take too long. I'll just pause it anyway. Alright, so now if we just play this through, we should see, there we go. Nice puff of smoke. So we obviously need this to be a higher resolution before we do the, for the final bake. But just for now, we want to check that the dust is actually suitable for this, this bullet sim. So it should, obviously I don't have footage of a real, bullet going through glass, but this, the puff should just roughly be about where these particles underneath it are coming from. So that's pretty good actually. First go, not bad. Congratulate myself there for that. I mean, it's just simulation tutorials, it's like anything can happen. So when something actually works first go, it's like, whoo, don't have to record this bit again. Temperature difference. Yeah, so that's the reason that smoke was rising just very gradually there, is because the temperature difference. So set that to 0 because this isn't a fire, so it shouldn't have any hot temperature to make it rise. And then we can also enable high resolution smoke as well, which could be good. Let's see how this looks now if we just give this a bake with just those new settings, and let's see how that comes out. Awesome. All right, so as you can see, smoke looks pretty good. I mean, you could tweak it a little more if you wanted, more of a puffiness at this end. Maybe. It feels so weird describing smoke. But that's pretty close. That took a really long time to bake as well, so I'm not doing that again. Yeah, I think it was like 20 minutes or something. But anyways, great. So now that's it. We've pretty much finished. Okay, that looks really odd. I hope that's not baked. Yeah, see this is the joys of simulations. Let's see if we can fix this cache here. If we just, for some reason the free or bakes button for Blender doesn't really work that well. So you have to like change these settings just 1 or 2 clicks, and then it'll actually free the bake. That button, free all bakes, and just used to be broken all across Blender in every area. Whenever it's mentioned, it doesn't free all the bakes. What's going on? All right, so rigid body's fixed. Particles, no. All right, so do I have to bake all the dynamics? All of them? Hope I don't have to do the smoke one again. All right, let's see if this works. Okay, cool. All right, fixed. Fantastic. All right. So now we can finally get into the materials, all important materials, lighting, and the final rendering. So first one's easy. We're going to select all this glass here, and we'll just give it very, very easy shader. It's pretty well picked for us, and then you just hit Control L materials to assign to every one of those objects there. If you want to check that it's on all of them, you can just change the viewport color a little bit, and you can see they're all blue. You want to do the same for the shards. These ones here, don't forget them. So just select all of them. Might as well give it a name so we can remember it. Glass materials, there we go. And then the bullet. The bullet's pretty easy. It's a mix shader, which I guess is pretty much the staple for nearly every material. At least I do in my tutorials. I don't know. It just seems to be every sort of material is just at the start. It's a diffuse and a glossy, and then you just go from there. Okay, so like that, and I'll set this to about 0.3. So mostly diffused, like that. So I'm giving the diffuse a very just a light sort of brown with a darkish tint to it, and then the glossiness, because it's actually metallic, we can give it an actual different color. And I'll just give that a very slightly blurry amount, 0.02, that should be good. And that should be the bullet. Make sure you just hit smooth on that bullet as well, and just so that the end of it isn't messed up, just give it an edge split as well. And now for the lighting. Previously, I think the first time I made this scene, I just used like a single plane overhead like this, and then you just give this an emission shader, set this to blue, and and then that lights it. But it actually, you get more interesting reflections if you use smaller planes like this, and then just duplicate it. Or to save time, you can use an array like this, and then make another array that goes in the other opposite direction like that. And now you've got like a little, like little overhead lighting. And that'll just create, just a few more little glints and reflections and things like that. And that'll just look a little nicer. And then you want to increase the emission amount for this to be like, let's try 30. And then, we can position the camera as well. So sort of at about there, just hit Control Alt number pad 0. In fact, you might actually want to move the camera just to its own layer as well, just down there. Cool. All right, let's just move this forward a little bit. Okay, that's pretty good. And then so we can get more reflections, because really, like, if you have a look at this, actually before we render, make the world background completely dark as well. And then we'll just give this a quick test render right now. See how this looks. There you go. So you can see like the glass is disappearing pretty quickly because the glass doesn't exist without reflections. Like, you can't really see it. Well, yeah, without lighting. Well, yeah, because the light can't actually hit it. It's there's no diffuse in there. It's entirely light. So it's relying entirely on the reflections and refractions and things like that. So you just have to make sure that everything else outside of the view of the camera is able to see everything. So I'm just adding a bunch of these lights around it, and I'll make these ones just a little bit less bright. I'll leave that one at 30. I'll just see how that looks with those settings. All right, not too bad. I can't really see the effect of the ones on the left hand side, so it's a good habit to actually get it's a good habit to get into. to practice just seeing how the scene looks with just one lighting setup, like just one light by itself, and then you can tweak that if it doesn't, Actually, I'm not really even sure I like this one here. I'm not sure what it adds to the scene. Sort of a slight softest diffuse. All right, it's not terrible. Let's see without the top ones as well. So these ones over here, so you can see the effect that these lights have on it. So I'll just increase that to go 20. And let's see all of those together. And that's not too bad. Now you can do another one as well, like if you wanted to have it at the back there. And then you can set this to not be visible to the camera, like ray visible, you just turn off camera. But because we've got the glossiness there, or transmission, glossy, transmission, it basically like turns off its usefulness. So it actually stops becoming a light. So it's just the way you do this with like the glass is pretty hard to get it to work so that it reflects stuff that's out of the view of the camera, if that makes any sense. Anyways, that's not too bad. It's pretty good. I would probably tweak this bullet material a little bit more. Maybe make it a little bit more rough, perhaps. Just a little bit. And probably just something like that. And the other thing you can do as well to give the scene an extra little touch is the motion blur. Where's motion blur? Right there. Screaming at my face. That doesn't make any sense. The end of the tutorial. And you lose sight of everything. Okay, motion blur. And the other one as well is the camera depth of field. So I want to make the object that's in focus. I'm going to make that the bullet just by selecting the bullet and just calling it bullet, and then selecting the camera depth of field bullet. And I'll just set this f-stop here to be 5.6, and you can kind of see a little bit of depth of field there, but not very much. I don't think you can really see it in the viewport, but maybe when we do a render, you'll actually see that stuff come into it. Yeah, there you go, the motion blur and stuff. So that's pretty good. Yeah, not too bad. Awesome. So the final thing that we need to, well, the final material we need to do is this smoke. Now, unfortunately, at the time that I'm recording this, Blender 2.74 does not let you render smoke with the GPU. And if I was to just switch everything over to the CPU, it would take forever to render. So what I advise you do, at least if you're watching this, I don't know, if you're watching this tutorial at a later time, maybe it'll be enabled, so just give it a try. But yeah, we have to move this to its own separate scene and set it up just so that you can render with CPU on that. So to show you what I mean, or just to do it, I guess, I'm just going to hit, well, actually, first of all, you want to select everything that is going to light it, as well as the camera as well. So everything that you're going to be transporting there, and then you're going to hit Control L. Oh, first of all, you need to actually create a new scene. So we'll call this one smoke, and then go back to the other scene, and then hit Control L, object to scene, smoke. So now if we go to this new smoke one here, we have to set the render engine to cycles. Like all the settings will be back to its default value, you know. Sampling, let's go 50, and let's take a look at these ones right here. Okay, cool. Now, to set up the material for the smoke, it's really easy. It's the most, well, I guess, yeah, once you remember it. But if you haven't used like rendered smoke in a long time, it's like, how do you do that again? It's a volume scatter node. You plug that into the volume input. Make sure it's the volume, not the surface. Very easy to get them confused. And then you want to use an attribute node to manually type out the word density, and that will reference the density of the volume metrics. It's crazy that it's been around for like over a year and we're still manually typing out the word density. If you get one character wrong, it's not going to work. That's no good. But anyways, then you want to use a multiply node in here, and this is going to allow you to change the density of the density value. So it's sort of like changing the density of this scatter right there, but only affecting this. So anyways, I'll set that to 10, and I'll just give this a shot right now. Let's give this a render just to see how this smoke looks. This should be fairly quick. Yeah, not too bad. You can see that the our sphere here is rendering. So you just want to make sure you go to the particle settings and just disable it from the emitter. In the render settings, disable the emitter. And I'll just change my performance. Because I'm using CPU, you want to use smaller tiles, whereas GPU, you want to use bigger tiles. And now that I've done that, we can go back to our main scene over here, disable the smoke so that we're only rendering that. And then we'll go to the compositor. It seems like it's getting very advanced, but I swear this is, it's almost at the end. There's one more thing we have to do as well. But now that I've done that, we can enable this new smoke as a render layer. And then to combine the two, very easily just add a mix node, and then take that, put that into the bottom input, and then set that to screen. And then when you do that, you'll get that result right there. So you can now just render both of them just by hitting F12, and it'll first render your main bullet scene, and then it'll switch over to the new scene, and then it will render out the smoke. So that is basically it. There is one thing though, if you wanted to render this as a animation, the problem is that at the start of this animation, where the bullet actually goes at the start here, well, you might want to turn down the screen value on that, so it's not too extreme. Yeah, not too bad. So yeah, as I said, at the start of the animation, where the bullet is actually traveling towards the glass, you don't want the glass to appear like this bunch of shards. And this is it's a common problem people have. It's like, well, if it starts as a bunch of objects, how can I actually render an animation? Because it's going to be very obvious to the viewer that something's about to break if it's already started as a bunch of pieces. So what you want to do is you want to make it so that the on frame 1, you can see we've still left our plane right here with the grease pencil attached to it. We can turn that off now. But yeah, on your first plane here, sorry, on your first layer here, you've still got the original glass plane. So what I'm going to do is I'm just going to give this the glass material. And then in your render layer settings over here, you want to set it so that, hang on, let me just make sure I'm getting this right. Okay. Right where it touches it, right where it begins to break, we can animate which of these layers it excludes from the render layer. So on render layer 2, we've got the broken pieces. Oh, and our lighting. So we should probably move that to the layer with the camera on it. Okay. So that now on layer 2, we've got just the broken stuff. Oh, and also the bullet. So let's move that to this layer down here. No, we can move that to the layer there. Okay. So layer 1, we've got just the clean glass. Layer 2, we've got the shards. So what we wanted to do is for frame 12, we want to be showing everything except the broken stuff. So right here, I'm going to click extrude, and then I'm going to add a keyframe on the extrudes, which I didn't even know you could do until I saw this in somebody else's tutorial. And then you want to do the opposite. So I'm now deselecting that, and then now I'm going to exclude the first frame for the rest of the animation. So it's now doing that. Like if you look at that exclude settings over here, if you flip back and forth between the things, it's now doing that. So that means everything before here, if we gave this a render, what we should see is just the glass plane with the bullet. And oh, it's going to try and do the smoke as well, but there's nothing there. And then everything after that, it should now be rendering as broken glass. And there you go. And that's it. So that's a really simple, easy way that you can render an object that looks whole up until the moment of impact where it shatters, and then it becomes that broken piece. So that's it, guys. That is a really advanced, really long tutorial. I know I might have lost a few of yous in there. Your head might be exploding from from all of this information, but it's definitely a challenge learning simulation stuff, but it's really fun. Once you've figured out all the quirks of the fracturing system and the rigid body sim, and you learn why things explode and all that extra stuff, like, it can be a lot of fun. So I'm kind of, I don't know, even though I've just been burned by this whole experience of making this bullet go through it, and it took forever, I kind of want to get started on another thing, like, I don't know, make a house explode or something plow through a wall. It's a lot of fun, so you can do a lot of interesting things with it. So if you make something cool with this tutorial, and I do hope you guys can use it for other things, please do post it in the comments section on Blender Guru. I love seeing what you guys make with it. Anyways, that's it, guys. Thank you very much for watching this tutorial, and I'll see you next time. Take care. Bye.